normal curve or the normal distribution. We looked at the normal distribution yesterday, and we were actually able to come up with some ideas. But now I'm going to prove to you why we need to know z-scores. So let's suppose that the scores on our last math exam were normally distributed with a mean of 75% and standard deviation of 7%. If we were to draw the normal curve from yesterday, we would start with our normal curve picture, start with the mean or the mu right in the middle at 75%. And then we'd go a standard deviation over on both sides, so up by 7%, 75 plus 7 is 82, up another 7% will give us 89, and up another one, so 75 plus 7 gives us 82, 82 plus 7 gives us 89, 89 plus 7 will give us 96, okay? And going backwards, okay, not a perfect normal distribution. This line should really be over there. 75 minus 7 is 68. Minus 7 again will give us 61. Minus 7 again should get us 54. Okay? And we remember from yesterday, from the mean or the mu, there's 34% here, 13.5% here, 2.35% and 0.15%, and it's carried over on this other side, shadowed, right? On this other side, okay? And we could use this to solve problems, and you guys have been using this to solve problems. So let's take a look. What percentage of students receive a grade higher than 89? Well, this one's good because we actually have 89 right here. Right? So it's actually from here and above. So 89, there's 2.35 plus 0.15. There's 2.5% of the students that received a greater than 89. Perfect. Okay? Now, what percentage of students received a grade less than 89? Well, we can do that. That is actually all of these, right? And so instead of adding them up, I know this percentage is 2.5%, and I know the whole normal distribution is 100%, so it's 100 minus 2.5, which is really 97.5%. Okay? Now, the other way you could have done this was to add all these sections up, right? 0.15 plus 2.35 plus 13.5 plus 34. But we have to remember the normal distribution is a whole 100%. Okay? Now, what if I asked you what percentage of the students receive a grade of less than 80%? Okay? Let's go back. Where's 80% on this graph? Somewhere in here, but do we know what percentage of 34% in that area is 80 and above or below? We don't really know. Okay? This normal distribution works great when they're specifically a standard deviation away. Okay? Now, if they're not a standard deviation away, they're somewhere in between, we can't use this normal distribution graph. We have to use something called the z-scores. Okay? So z-scores are great. You need to know how to calculate a z-score. A z-score is a standardized value that indicates the number of standard deviations a data value is above or below the mean. Okay? So in order to calculate a z-score, we find a value. Okay? So there is an actual formula for the z-score. And that formula is z is equal to x minus mu all over the standard deviation. Okay? And we know that mu, that's just another way of saying mean. This sigma that standard deviation, this Z stands for Z-score, okay? And X, this is just the number you're looking at. So in this case, in our question above, 80% would be our X value. Okay. If you end up with a positive Z-score, that means your data point is above the mean. If you end up with a negative Z-score, it indicates that the data point is below the mean. So let's go back and just see what we have. We had a mean of 75 with a standard deviation of 7, and our special number is 80. So if I put this in to find my Z-score is equal to 80, that's my special number, minus mu, which is our mean, 75, divided by our standard deviation, which is 7. So 80 minus 7.5, that's 5 divided by 7, which will give us a decimal. I'm just going to pull up my calculator here and go 5 divided by 7 gives us a decimal 0.71428. 0.71428. Okay. Now with Z-scores, we take them to the second decimal always. Okay? So in this case, our Z-score is going to be 0.71. It's positive, which means it is above the mean. So if I were to draw my little standard deviation curve or my normal curve, okay, this is my mean, right there, that's my X bar or my mu, 0.7, okay, somewhere on in here, and we write our Z-score of 0.7. We need to know the percentage. Now let's look back at the question, that receive a grade of less than 80, okay? So less than 80, that's all this stuff on this side, okay? So what I'm going to do is I'm going to show you our Z-score tables, okay? So the Z-score table, you get a really big sheet. It goes from Z of negative 2.9 all the way down to 0, okay, all the way down to 0. And then your second page is your Z-scores for positive, from 0 all the way to 2.9, okay? Now, our Z-score is positive, so we're going to look off of here. You'll notice all the numbers that are positive, 0, 0, and so we match it up. Here's to the ones, or to the tenths, and this is to the hundredths. So our number is 0.71. So I go down to 0.7, and then I go over, so I get that 0.1. 0.71 matches up right here. Some people take highlighters, take markers, and they go, okay, well, 0.7 is here, 0.01 is here. This is that number, 0.7611. What does that actually give you? That gives you the decimal percentage that is below the line, okay? And so I'm going to go back up here to this top section here. Every value in this table, whatever the Z-score is, it gives you the percentage that is on that side, okay? So you have to realize that. It makes sense then, at the mean, you're at 50%, right? At 0, 0 Z-score, you're at 50%, okay? So positive is above 50, negative is below 50, and you really have to watch your question. So in this case, our question was, what percentage of students receive a grade less than 80%? Well, that's 76.11, because it was decimal 7611, but that's in a decimal percent. And when we change it into percentage, we want to write a percentage sign behind it. So it actually, you multiply by 100, and you get 76.11% of the students that receive 80% or below on that test. Okay? So moving forward, oh, we did that. Back to the example above. We did that. Let's take a look at how we actually look at z-scores. Before we can use them, we need to practice calculating the percentage. So to the left is just the left on your paper. So if we have a z-score of 1.31, remember positive appears past the line, so 1.31 would be here, and to the left, that's all this stuff in here. Okay, so let's go look up 1.31. Okay, 1.31 is positive. I'll go to this side. I look at 1.3, and I go to 0.01. So 1.3 and 0.01 here, that's 0.9049. Okay, and remember, that's what's to the left. So that's the real answer, 0.9049. Okay, so 0.9049. If you want to change that into percentage, that's 90.49%. So the next question says, to the right of a z-score of negative 0.76, we are to draw this picture. Negative is on this side, so negative 0.76 is here. We want to know to the right. So right is this way, so we want to know everything here. Remember, the picture that we get gives us everything to the left, right? So we're going to get this number. How do we actually get this number on this side? Well, that's 100, because this whole distribution is 100, minus whatever value we actually solve for. So coming back here, we're looking at negative 0.76. So I'm coming here. Negative 0.7 is way at the bottom here. And I've got to go over to 0.6, which is here. Scroll down. That gives me 0.2236. So going back to my question, 0.2236, which is 22.36%. That gives you 77.54, 64. Okay. Hopefully I can do the math in my head. If not, you'll fix it for me. Okay. So question C here says between 0.21 or between negative 0.21 and 1.35. So draw your normal distribution. I always draw this. Put the middle as the mean. Put your negative 0.121 here. And I've got my positive 1.35 here. We want to know what's in between here. How do we get in between? Well, if we look at negative 1.21, it gives us this. If we look at 1.35, it gives us all of this. So to get just what's in between them, I will take whatever I get my z-score for 135 and subtract off what I get my z-score for negative 121, and that'll give me what's left, right? Because if I take this whole blue line and I subtract off this little black line, I get what's left in the red. Okay, so let's take a look at 1.35 and negative 1.21. So negative 1.21 is all the way over here at 0.1131. Okay. So I'm going to go write this down. 0.1131. And I'm putting that right underneath that 1.21, that negative 1.21, because that's the value that goes with it. I'm going to go back and look up 1.35. That's on the other side. 1.3. Go over to 5 is 0.9115. Okay. 0.9115. Now, remember we said to get in between, we're going to subtract them. So whatever 0.9115 subtract 1131 gives me 4. Borrow gives 11, gives 8. Borrow again gives me a 9. 8 minus 1 is 7. So 0.7984, which is really in percentage 79.84%. I think you get the point of this, so we're not going to do more. We'll do more in some wordy examples, okay? Now, before we get into wordy examples, you can go backwards. Okay. So, to go backwards, you kind of still got to draw out the situation. It says 45% of the data is to the left of the z-score. Okay. So if I draw this out, where's 50% again? That's right in the line, right? So left is this way, and 45% of the data is to the left. So this is 45%. I want to know, what's this z-score? What's this value down here that'll make 45%? Well, this is where we go for like a little hunting mission. So we come over here, 45%. We know it's going to be a negative z-score. Why? Because it was to the left of the mean when we started. And we just hunt in here. Okay, where is about 45%? That will be 0.45. If I look way down here, I get 0.43, 0.44, 0.448, 0.4522. So I'm kind of stuck in between 0.4483 and 0.4522. You know what we do? We pick the closest one. 4483 is about 0.0017 off. This is 0.0022 off. So it's actually this one. So it's negative 0.13. So the z-score will be negative 0.13. So you do the opposite. You look for the 0.45%, like the 45%, and then you read backwards to find your z-scores. Okay. So let's look at this next one. 30% of the data is to the right of the z-score. So if I draw this, 30% is to the right. Well, that means we're up here. This is 30% in here. But realize our z-score table only reads to the left. So what's left over? 70%. Okay? I know 70% means it's above the mean. So when I go back to this page, I've got to look 70% over in here in the positive section. So we're searching somewhere in the middle. If I look here, I've got 0.6985. That's about 0.0015 off. And I've got 0.7019. That's 0.0019 off. So my best answer is this one here, this 0.6985. Read back, gives me 0.5. Read up, 0.52. Okay? So, coming back here, 30% to the right is 70% to the left, which will give us 0.52 of our z-score. It is positive because it is to the right of that mean. Right? So we're going to look at a couple examples here. The average time spent in a hospital following a certain surgical procedure is 200 hours. So average time, that's your mu, that's your x bar, with a standard deviation of 15. 1,000 patients were sampled. What is the probability that the random chosen patient will be in the hospital more than 220 hours? Okay, so this is your x right here. That's just your special number. 200 hours, that was your x bar or your mu, right? And this 15, that's your standard deviation, right? So we can come up with our z-score. Z-score is x, 220, minus your mu, or your x bar, so 200, divided by 15. So this gives me 220 minus 200, so that's just positive 20, divided by 15. That gives me 1.33 repeating, right? I hope I did my math right there. 1.33 repeating. You can just do 20 divided by 15. That's our z-score. So if we draw our picture, we want 1.3, that's positive, 1.33 here. We want to know more than 220. So that's actually over here, right? More than. When we look up our value, we're going to get what's on this side. So we're going to have to go 100 subtract whatever we get. So back to our little chart here at 1.33. 1.33. I get 0.9082. Okay. 0.9082, so it's 90.82%, which when we subtract it will give us 9.18% will be more than. Okay. If you want to try this one, you could try less than 175 hours. I think you guys will have an idea on this. We're just going to take a look at question C, because it's slightly different. It's not asking for a percentage like this. This is saying what's the probability or what's the percentage that some patient will end up this. The next question says how many. Okay, so this is actually asking for an actual number. How many of the patients were in the hospital? Okay, between 190 hours and 210. Okay, so if we were going to draw it, we'd actually end up with two lines and we need to go in between, right? But how do we know where the z-score actually falls? Well, we have to do two z calculations. One where the x is 190, so 190 minus 200 divided by, what was our standard deviation? 15. Okay? Divided by 15, this will give you negative 10 divided by 15, which will give you negative 0.66 repeating, so negative 0.67. Right? The other z-score we need is from 210, 210 minus 200, all divided by 15 will give you a positive 10 divided by 15. 10 divided by 15 is positive 0.66. Okay? Repeating, which is going to be a positive 0.67. Okay? So if we were to actually fix this drawing that I did here, here's your mean. It'll actually shadow on both sides, right? So it should be the same thing. Okay? When we look up the z-score for 1, it's going to give us that amount. When we look up the z-score for the second one, it'll give us that amount, and we can subtract to get what's in the middle, right? So going back to look at our z-scores, negative 0.67 is right here, 0.2514. That's actually this z-score, right? 0.2514. And we're going to find the positive 0.67. Positive 0.67 is right here, 0.7486. .7486. We got to subtract them to get the actual percentage. So 0.7486. If I do a subtraction, we get 0.4972, which is 49.72%. Okay, that's a percentage. The question didn't ask for a percentage, it asked for how many. So going back to this question, it told us there's 1,000 patients. So what do? We take that 0.4972, that's in decimal percent, and we times it by the 1,000 people. Okay? And when we do that, we're going to end up with 497.2 people. Now remember, you can't really have 0.2, so you should always round down because you're for surely going to have 497, but you're not sure about that 498. But remember, we talked about this, we could say 497 people, or you could say 497 to 498, but in this case, with it such a small decimal, it's probably better to say 497. Right? Now, this is just another question. How many hours following surgery will it be until 75% of the patients having this procedure have left the building. Okay, so what we're saying is 75% have left. So we're looking at this picture. This percentage in here, this is 75%. Well, in order to know ours, we really need to look at our Z-score, right? Because our Z-score is equal to X minus your average all over your standard deviation. Well, we know our average was 200 and our standard deviation was 15. They want to know how many hours. They really want to know what this X is after 75% have left. Well, using that 75%, we can go back and find our Z-score just by looking here, finding that 0.75, right? We're going backwards. 0.75, we've got here 0.7486, or we have 0.7517. Now, here's one thing to think about. We want to know when 75% have left. Well, here, this is 74.86%. Okay, not quite 75. So, for it to be 75%, you really should use the one that's 75.17. Just because you know for sure 75% have left them. So that's 0.68. Okay, so coming back here, that's when it's 0.68 for my Z-score. 0.68 for my Z-score, X minus 200 all over 15. Well, we can do this a couple ways. We need to solve for X. You guys really like this line equals line, so I make this thing over 1 and we cross multiply. So 0.68 times 15, 0.68 times 15 gives us 10.2. So I actually get 10.2 is equal to 1 times X minus 200. Okay. How do I get X? Well, we add 200 to both sides, and we get 210.2 hours is the time it takes for 75% of those people to being kicked out or left the hospital. Everything's done. Okay? When I look at the next kind of questions, they're the same things, just different words. Okay? So you look to see, are they giving me a standard deviation? Are they giving me a mean? Are they just giving me one random number, which will be X, and find the Z-scores? I think I'm going to leave it at that because we're running close to the 30 minutes. If we need to go through some more of these, we'll go through them when we come back on Monday. But this should give you enough to get started on your assignment. Your assignment is on page 264. And you're going to do questions 5 to 9 all. Okay. And I think those go A, B, C, D. If you just do like A, B, C, I'll be happy. And then question 10 to 15, and you choose if that's odd or even. Okay, so you can do 10, 12, and 14, or 11, 13, and 15. Good luck and goodbye.